All right, hello class. Let's go right into what we're going to talk about today, sliding filament theory. Lots of different parts and chemicals and compounds and structures that are all going to go into making sliding filament work, right? And sliding filament is a very simple theory, and let's get right into it. We'll start with some of the anatomy. So we start off with a bone, right? We have muscles that are attached to bone through tendons. Muscles themselves are broken down into many different subunits, and we're going to start with the biggest one, the epimysium right here, which is the muscle belly, people will call it. There's a lot of different connective tissues involved with muscle, right? It holds it all together, it gives it strength. So then you have the perimysium, which is inside the epimysium and contains these things called fascicles. And fascicles is yet another subunit of muscle, right? These fascicles are comprised of the endomysium and then a lot of other little fibers called sarcolemma. These sarcolemmas are actually the cell of the muscle. These are the individual cells of the muscle, right? And they have nuclei on them. That's where the cell gets fed and all that kind of stuff happens, right? It's right here in the sarcolemma. Inside the sarcolemma, you'll find myofibrils. This is really the focus of sliding filament, because what goes on inside the myofibril is sliding filament, okay? So I've made a big circle here, right? Because I then drew a myofibril larger right here, okay? So the myofibril is comprised of a lot of other parts as well, right? So on the outside of the myofibril, right, we have that sarcolemma, and here it is. This sarcolemma is the red lines and the dots. Those will be important in a second, right? And inside that sarcolemma is a bunch of myofibrils, right? And myofibrils are actually made up of a lot of other subparts too, right? And so one of them is T-tubules, another one of them is sarcoplasmic reticulum. These two parts of the myofibril are very important because it moves calcium around those myofibrils, which is needed to do muscular work, right? We need calcium to make this structure here come together and contract, right? And we'll go over that in a second. So on the sarcolemma will be an alpha motor neuron, right? And that's when I tell my brain I want to move my arm, right? I'm going to send a signal from the brain to the alpha motor neuron, right? It's going to come down as what we call an action potential, right? And this chemical called acetylcholine is going to be released across what we call the neuromuscular junction. Basically, what that means is where the neuron and the muscle meet, right? And again, this is the sarcolemma. When that acetylcholine is released, the sarcolemma can then release calcium through the T-tubules and the sarcoplasmic reticulum. And again, that bathes the myofibril and gets movement started within this structure here, which I actually drew a lot larger over on this side. And you can see right here, right? We have a bunch of different fibers in here as well. So we have myosin, which is drawn in this red chalk. And on the myosin, we have globular heads. Globular heads are really important, right? Because that's what actually grabs on to what we call actin. Right here is our actin, right? And actin has a bunch of fibers on it as well. So when that calcium got released, right? It got released through the sarcoplasmic reticulum and the T-tubules, right? When that happens, this piece here, the tropomyosin, this fiber here, the tropomyosin, moves out of the way of what we call binding sites. And these binding sites are important because that's what the globular heads of the myosin are actually going to attach themselves to. And when they attach, that's going to draw them in together. Okay, it's going to draw in the actin. The actin is going to move from here to here, right? Thereby shortening our muscle. And that is really the basics of it. If you need to re-watch this video, feel free to do so. We're going to go over it in class together. And then you should have a really good solid understanding of it. I'm going to have a bunch of slides to show you guys. It should be pretty straightforward. And once you get it, it's kind of hard to forget. It's a very simple system. As I said, it looks complex, but it really isn't. Thank you.